Good morning, everybody, and welcome again to another OpenShift Commons briefing. Today we have some of our friends from Tigera, other Commons members, and they previously did an older demo, which they'll probably talk about a little bit before in a briefing. But this is an update on what they're doing with their enterprise-grade network security, OpenShift and Tigera CNX they're offering. So I'm going to let them introduce themselves and their topic. As always, the format is ask questions in the chat, and we'll have live Q&A at the end. So, and the slides and everything will be updated and added to the blog at OpenShift.com. So go ahead, take it away, Amit.
Thanks, Diane. Welcome, everybody. Today's topic for this briefing is implementing enterprise-grade network security with OpenShift and Tigera CNX, which is our commercial offering. My name is Amit Gupta, Vice President of Product Management. I'll be co-presenting today's session with Karthik Prabhakar, who's Director of our Solution Architecture. Karthik?
Yeah, hi folks.
Today's agenda, what we want to cover today is we want to walk through with you a couple of trends that we are seeing with our users in the market. I'll also go through a detailed overview of what Tigera CNX solution looks like. We'll also present a case study of a common customer who's using OpenShift and Tigera CNX to secure their networks. And in the end, we'll wrap up the discussion with a live demo about how these capabilities work together. So we have a lot to cover today. I'll jump right into the discussion. So here's an example of how some of the trends that we are seeing in application development and also deployment. So if you look at today how applications are built, there's no more those big, large monolithic applications that are built with tightly coupled libraries. In fact, what we see today is a set of microservices that are loosely coupled together around well-defined API contracts. We also look at these applications. They're no more deployed as stateful, large, bulky virtual machines, but these are small, stateless containers that are deployed in an automated fashion through deployment automation through their CI/CD pipeline. So when a developer checks in a code, it takes a few seconds for their actual code to get deployed into their production infrastructure, automated through their pipeline, and obviously through these dynamic orchestration tools. And last but not the least, these applications, they're not anymore deployed in what we call as dedicated application siloed infrastructure. In fact, these are hosted on a fairly elastic, fairly seamless, boundless infrastructure that may or may not go across your data center boundaries. So what does this implicate when it comes to your underlying network architecture and how you secure these applications? So fundamentally, the fact that you've broken down your application into small microservices, a very large monolithic application is now split across many, many different microservices. So fundamentally, your workload count has significantly increased. Now, also because these applications are fairly transient, like if you compare a normal virtual machine-based application will be around for 50 to 100 days before it is recycled with the new code. When you compare that to what the data says about container-based applications, those are around just for a day or two on an average. So in that model, it poses a significant strain in your underlying networking architecture and how you secure these applications. Just because you have 10 times more workloads means you have a bigger attack surface that you need to secure. Also, because all these workloads are so transient and they're constantly changing, which means that your underlying network infrastructure goes through a significant churn as compared to what you may have been dealing with in your legacy applications. So what we're going to do today is we're going to focus on both these aspects going forward for the rest of the session. So how do you manage the significantly dynamic set of changes that go down all the way to your network infrastructure? And then how do you actually secure your applications and the entire attack surface that you have with respect to these microservices. Now, as we think about a solution for these two broad problems, a lot of feedback that we have received from our users is grouped around a few areas. One is, as they think of a solution, it has to work with the various organizational boundaries they have. What I mean by that is, just because you have changed the application architecture and the fact that you have new needs on your network infrastructure doesn't mean that the separation of duties that you have in your organization is going to change and go into different organizations. Your global corporate security teams are still required to manage broad security rules that need to be applied to each of these applications. At the same time, the individual application owners or operators of that application know best what the network topology for that application is and how those should be set up. So the solution has to honor these set of boundaries. The second aspect there is, while your application and the set of microservices are truly cloud native, it's very likely that rest of the infrastructure and rest of the applications that these microservices talk to are not. In which case, we're looking at a deployment model where these microservices need to talk to your data sources, your log aggregation systems, your API gateways. Fundamentally, the solution that you're going to put in place for securing these applications got to work with all form factor, because the world is not as homogeneous as we would like it to be. The third aspect that we hear from our users is around making sure that the security architecture and the implementation approach is operationally simple. There's a lot of complexity that already exists in these enterprises and these deployments. And when it comes to managing security for these modern applications in conjunction with these legacy applications, the best approach there is to have not a very hierarchical or complex system, but essentially something that works seamlessly with that. And last but not the least is, how do you make sure this architecture and this approach actually works seamlessly with all infrastructure? Now, obviously, you get some benefits of that by running it on Kubernetes-based infrastructure, but when you actually enforce security across various different environments, it's super critical that this all fits together in a way where that you have a normalized security approach and you're not reinventing the wheel every time you need to look at a different infrastructure. So those are some of the key feedback that we have received from our users, and fundamentally, those are the key pillars of the Tigera CNX solution. And I'll go through each of these in details, but our model or our recommendation to the users is that they should essentially deploy a zero trust network security model where you are protecting your applications from both internal and external threats without making any assumptions about either the underlying network, the resources, or workloads. I will go into more details there. As you deploy the zero trust network model, it is very critical that you make it work with various different forms of infrastructure, both for your new modern applications, but also your legacy infrastructure. And it has to work with the various RBAC models, with various organizational boundaries, and the separation of duties that your organization may have designed for various compliance regulations and so on. So those are the key themes of it. Let's jump into each of these aspects. So zero trust, very basically described, the philosophy around this model is that you protect your applications as if they are all sitting on public internet. What I mean by that is it's very likely that almost all of you guys have advanced persistent threats in your environments, or various malware, sophisticated malware that are lurking inside your network. And if that is indeed the case, then you design a security model that essentially requires identification from multiple sources, enforcement of policy and security at various different locations. We prescribe a four-pronged approach to a zero trust model. So one is authentication, second, authorization, encryption, and inspection. So when it comes to authentication, assuming you have these threats lurking around in your environment, would you trust or would you believe a workload asserting a certain IP address and building your security around just that network identity? More than likely not. What we propose and implement through our solution is providing each of the workloads a cryptographic identity. And as you bake and define your fine-grained access control rules around these applications, you incorporate multiple sources of these identities in the validation process. The second aspect is how do you authorize these workloads in terms of connectivity and access to various different resources. So the first aspect is definitely whitelist everything. So by definition, you deny all access, and then through intent-based declarative rules, you define which application is allowed to talk to what. And as you define these whitelist rules, obviously we're going to validate the identity based on both network and cryptographic identities, but we also enforce these whitelist rules across multiple enforcement points. And specifically, those are one at the edge of your application, at the edge of your pod, and also at the edge of the host. So with that model where you have enforcement at these three different layers, you have a fairly comprehensive security for your applications. The third aspect is encrypting everything. So all the payloads are encrypted, which means that you really don't have to make any assumptions on the underlying network. Now, what this does is you have either completely mitigated or minimized the attack surface, the new attack surface that you had generated by creating these microservices or these 10x workloads we talked about earlier. You also get various different compliance rules checkmarked because now you have proper segmentation on your workloads, you have encryption in place, you're constantly monitoring that, and you have also eliminated any kind of sophisticated, complex internal and external threats in your environment. So it's a very critical aspect of our security model across these pieces. The second aspect is around your multi-cloud and legacy infrastructure. So as I was talking about, more than likely your applications in these microservices, they're talking to various different resources in your infrastructure. Either they are sending logs to a log aggregation system, they're talking to API gateways, they're talking to corporate data centers, LDAP stores, a whole bunch of shared services. And it's very, very common to not implement a fine-grained security model across these disparate systems because it is so hard to do that when you are dealing with security in different models across these different systems. And that's fundamentally what we solve with Tigera CNX, which is we provide a unified, consistent policy enforcement model that works across your heterogeneous infrastructure. So whether these resources or workloads are running as pods or virtual machines or even bare metal infrastructure, you get a very seamless security implementation model, works across various different infrastructure, and you can enforce a common security model across these various different workloads. The third aspect is around how do you actually enforce your organizational model, and once you've designed the security architecture, how do you actually operationalize the security architecture as per your your control and compliance policies. So a couple of key capabilities that Tigera CNX offers is the ability to define role-based access control around who can define what security policies. A very simple example there could be that within an organization, you have your global InfoSec organizations or cybersecurity organizations that are responsible for defining broad set of rules around compliance, whether it's around PCI, SOC 2, export compliance. They're also implementing a whole bunch of corporate security workflows around quarantine, forensics, and various different scenarios. All of that could be broadly enforced using this resource-based access control, but at the same time giving your application developers or cluster operators granular permissions on various set of rules around applications that could be enforced by them without compromising the broad set of rules that are created or managed by your core security organizations. All of this is also available through a very comprehensive audit mechanism. So for each of these policies, you can set up various different audit logs, you can set up thresholds, alerts that allows you to integrate any policy violations or compliance issues directly into your security workflows. So the key aspect here is that you leverage your existing organizational model to enforce these policies, integrate with your existing workflows. If you want to send some of these alerts and audit data to your security operations centers or log aggregation system that is seamlessly integrated, we manage a detailed time series data for various metrics that we are collecting from your workloads. And again, all those metrics could be integrated with your threat analytics system, so you can profile the network traffic, you can look for legitimate, illegitimate traffic, you can look for anomalies, indicators of compromise, and as you discover or uncover those aspects, it could be integrated in your incident response workflows. So all of that, in terms of the security architecture we talked about, can also be very seamlessly operationalized into your existing security infrastructure and workflows. The last piece around this set of capabilities is around the networking architecture. So one of the key aspects of a zero trust security model is you break down the complexity that you have at the traditional hierarchical enterprise networks. The flat IP networking model is essentially gives you the simplified networking model where you can enforce security without having to deal with the complexity that comes with those hierarchical networks, where it's super hard to go through any kind of either troubleshooting, diagnose, metrics, and so on. So we provide a flat IP networking model with the capabilities around whitelisting the traffic and managing fine-grained security on top of that, keeping it very seamless for your SREs to manage their service level objectives or even their SLAs they need to meet for each of these applications. Today, I'm not going to go through a whole bunch of architecture details, but a couple of things that I do want to call out. The CNX solution is built on top of various open source projects, including obviously our flagship Project Calico, and baking in some of the core capabilities from Istio into this architecture. That's how the solution comes together. Beyond some of these core capabilities, we believe we also have a very better together story with OpenShift as the underlying platform. So in the most recent release of CNX 2.1 that's coming out shortly, we have done a much more simple installation process. So you can actually use OpenShift and Ansible to go ahead and install CNX in your environment. We have done OAuth integration. So from a login experience perspective, it is truly seamless for OpenShift users. We also extend the OpenShift API server, so you can use the OC command line to apply any kind of CNX configuration and manage those rules. And then last but not the least, this is offered as a supported solution for our users for both Tigera and Red Hat. So let's look at a quick summary of how each of these capabilities line up. So obviously, as an OpenShift user, there are some base set of capabilities that are available out of the box. So you get the CNI networking, you get the Kubernetes network policy API implementation. With Calico, which is our open source project, you get some additional capabilities on top of that. So you can now do direct infrastructure peering without setting up any kind of overlay network. So you get that flat IP network. You also get an advanced network policy model, which is part of Calico. So that gives you capabilities for additional protocols, any kind of negative matches. You can do host protection along with that. Global policies, we also have capabilities that we recently added around network sets for implementing rules for traffic going in and out of those resources that are not necessarily running on OpenShift. And then last but not the least, we have recently added application layer policies integration with Istio. Now, when you look at on top of that, what CNX offers in conjunction with OpenShift. So as I talked about, the separation of duties and the RBAC controlled policies that's aligned with your organization model. So you can have your global security organization define policies, you can have your cluster operators define policies, and you can have your application developer manage fine-grained control around their applications, and all of that will work seamlessly with various controls defined around that. We also offer capabilities around federating your workloads across cluster boundaries. So what this allows you to do is if you have distributed applications or common services that are leveraged across cluster boundaries, you can configure that and manage that through CNX. As I mentioned, there's a various set of metrics that we would publish into we would monitor your policies, and we would provide security violations and alerts around these metrics. Each of these data sets could then be piped back into your security operation centers or any kind of threat analytics platform, and that gives you a fairly integrated security workflow. We have also integrated our UI, CNX Manager UI, login experience with OpenShift, so you can continue to use your OpenShift OAuth tokens when you get into CNX Manager UI. And there's a lot of policy diagnostics, troubleshooting capabilities that are available in CNX, which essentially allow administrators and SREs to manage any kind of service down situations, or when you have actual policy changes that may impact underlying services. Let's switch the topic and talk a little bit about a case study that I want to present to you guys. So today's cars and vehicles, they on an average have more than 100 plus CPUs inside. All of these vehicles, they are actually smart endpoints in a very global distributed IoT network. Now, what does that mean from a car manufacturer's perspective? What that implies is that as they look at various streams of data and various capabilities that are centrally integrated into these vehicles, they actually have to think about how they deploy various applications and manage these capabilities in a fairly innovative and dynamic fashion. So this specific example is about a similar global auto manufacturer who is essentially renovating how their applications build their application and deploy these applications in a fairly modern infrastructure in a modern architecture. And they rightfully so chose OpenShift as their platform for their containerized applications. So they're building a self-service platform for these containerized applications that will be offered to, the platform will be offered to these developers. Now, the key challenges they run into there was, while they did pick the right platform in terms of the container as a service offering for the developers, there was still a lot of old arcane network infrastructure that was not working very seamlessly with this modern infrastructure philosophy. They had network security devices, appliances that would take several months to change ASIL rules, primarily because they were not designed to work with these dynamic environments. At the same time, they had this requirement to enforce security across various different organizational boundaries, which means they wanted developers to be able to manage security for their own applications and be able to do that in a self-service fashion. But then they also wanted the security organizations to be able to define broad set of rules that are enforced across all of these applications. So fundamentally, they were in this situation where they could either choose a model where security is enforced manually, in which case they would compromise the benefit of this platform and the self-service, compromise the agility. Or if they go with that, then they have to compromise on fine-grained security controls that needed to be enforced on these applications that are connected and working with devices, resources that are across their data center boundaries. So there was a tug of war between agility and security. They could choose one or the other, and that's where Tigera CNX comes into play, is be able to provide both and not have to compromise between agility or security. So they've deployed Tigera CNX. They are managing their fine-grained policies across our platform. They have defined various different global tiers around how these policies are created, who has access to those policies, and these policies, as you all know, they're built on dynamic application constructs. They come with full audit and logs that meet their compliance needs, and it serves the security and compliance needs across their entire platform and the applications hosted on that infrastructure. It's a very quick example of how this works. So in their case, they have three broad set of tiers defined. One is for the information security group, and they're defining broad compliance level policies in terms of what kind of application traffic is denied, what is aligned with their PCI certifications, and so on. Compliance audit log being collected and sent to certain systems. Then the platform team is managing various set of policies and the delegation model for the individual workloads. And then last but not the least, the development teams are managing specific set of policies for each of those applications. So we have this hierarchical execution model where all of these application tiers and policies are enforced in a streamlined fashion, managing, organized around their separation of duty boundaries. So with that, let me transition to Karthik, and he's going to walk us through some actual live demos around these scenarios.
Thanks, Amit, and give me a second while I start sharing my screen. In fact, just want to make sure you guys are seeing it. Okay, perfect. Good. So, continuing a little bit from where Amit left off, I see a little bit of lag on the screen sharing, so that's fine. I'll try and coordinate. I'd like to walk through specifically 3 demos that cover a couple of the use cases that Amit talked to. And specifically, I'd like to walk through the enterprise control and compliance scenario with a demo. And also, along with that, walk through a PCI compliance scenario. This is actually a synthetic scenario, but it sort of mimics something that we've had a number of customers do in a similar sort of model as well. So I'm going to walk you through that. And the third element, the second sort of part of that PCI compliance scenario involves workloads that span not just pods in OpenShift, but also virtual machines outside of OpenShift. One thing you'll notice about CNX is that it is a heterogeneous platform. Obviously, it has become, CNX has become and Calico specifically have become the de facto standard for connectivity and network policy in platforms like Kubernetes and OpenShift. But that said, it also does support other orchestrators such as OpenStack, and in addition, we can also use it for protecting workloads that are bare metal Linux hosts as well as cloud instances. And so when we walk through this PCI compliance example, I'm going to use a workload that spans multiple platforms and how we can enforce this compliance policy independent of where that workload is running. And then the third sort of demo I'll walk you through is a few security operations and network operations workflows involving sort of the different elements of monitoring, alerting, and audit logging that you might require. But more specifically, I will sort of point out how, although I'm doing this in an imperative fashion here to show you what's actually happening, these are all designed to be automated. And I think this reinforces the comment that Amit made that many of our customers are struggling with is the fact that OpenShift itself provides a very declarative and automated platform for applications. And in fact, the underlying infrastructure itself is typically deployed as code, whether it is the compute instances or even the networking. Today is intent-based networking typically, where you declare your model and then you have your infrastructure conform to that model. But very often our customers are struggling with the layers in between, which are not yet automated and dynamic and declarative. And specifically, CNX is focused on helping move that infrastructure layer between the actual compute and network infrastructure and the application platform to also become a more declarative model. So I'll give you some instances of that. Okay. To sort of illustrate this example, I'm going to use a synthetic application. What we have is an application called Stars, which is a microservice application, where there is a client which happens to have a set of labels. This client is, has a label that says role equals client and compliance equals PCI. In the case of CNX, what we do is you can sideload these labels for an application when it is running in a virtual machine or in a bare metal host. Or in the case of Kubernetes and OpenShift, we simply inherit the labels from OpenShift. And part of the reason for that is because the team here at Tigera helped develop the network policy model in Kubernetes. And so what you'll find in Kubernetes and therefore in OpenShift is a model that very closely mimics our model for network policy, including things like labels. So in addition to the client, we typically have a few microservices. So we have a front-end microservice where you have a set of labels, including one that says compliance equals PCI. We have a couple of microservice Bs, which are serving as a backend, which also have this label where one of those microservice instances has a label that says compliance equals PCI versus another one, B, which does not have that label. So in effect, what we'll do when we get to that compliance example, let's demonstrate how we can isolate PCI compliant workloads from non-PCI compliant workloads based on the label. And finally, we have another application or a different part of the application tier, which is a database, which is actually running outside of OpenShift, and we'll walk through that. In this case, it's actually running on a virtual machine instance in the cloud. But in this case, we do have labels associated with that instance as well, which says where one of the labels says compliance equals PCI. And when we get to the application, we'll show in the UI for the application, the solid bars reflect that connectivity is being attempted and is possible, versus the light bars where connectivity is being attempted but not being allowed, and typically that would be by network policy that is preventing that. So that said, let's sort of switch to my actual demo, and I have a OpenShift environment running here. Let me first log in as. Okay, and again, actually that is the wrong UI. Sorry, I should have gone to my OpenShift. Okay, so there's my OpenShift console. Now, you saw a little bit of a preview there. What I'm now going to show you is the CNX Manager interface. And what you'll see when I get to this, you'll notice that this immediately redirects you back to the OpenShift dashboard. Let me log back out. And when you log in, the first thing it does is it brings me back to the OpenShift dashboard. So I'm going to log into OpenShift here using my OpenShift credential. And first, let me log in as a user Bob, where I've given Bob permissions. I'm assuming Bob here is a developer, so I've given him developer level permissions in OpenShift. And what you'll see when I log in is Bob, ignore that license tracking thing. That's I need to fix that for Bob. But in effect, what you'll see is when Bob logs in, he sees the default network policies that he has defined for this application. And specifically, you'll see a number of Kubernetes network policies in the default network tier. And this is what you get when you have an application and you define network policies via Kubernetes. So coming to the application view itself, here's the application view. This is the actual application that's running. Give it a couple of seconds to pop up here. And in effect, this is a view of this client microservice talking to the front-end microservice A with the label PCI compliant. And A is talking to a couple of back-end microservices, which in turn are talking to a database running outside of OpenShift. I'll make this simpler so you can see it without that dynamicity. So now coming to this thing, so obviously these network policies are being defined for this application by the developer, in this case Bob, and so all of the faint lines that you see here are what are being implemented by Kubernetes network policy, where in effect Kubernetes network policy defined by Bob is saying that the client is allowed to talk to the front-end microservice, the front-end microservice can talk to the back-end, and the back-end can talk to the database. And everything else, such as the client talking to the database directly or the front end talking to the database directly, is not permitted. So now let's log out as Bob. Oh, in fact, let me actually do one more thing here. So now as Bob, I've given Bob permissions to not create new policies. And this is done via OpenShift RBAC. So let's say I create a new test policy and put it in a given namespace. So by the way, Kubernetes policies are namespace friendly. Obviously, in CNX, you can have global policies as well. That's a feature we have. You can have ingress and egress policies. And you can choose to use just the Kubernetes network policy syntax, which gives you fewer features. Or you can use the Calico policy syntax, which gives you a lot more features, including log actions, deny, pass, and so on. So in this case, I'm going to say, Bob is trying to create a policy that says allow UDP port, let's say 53 for DNS. And he saves that, saves the rule, and let's say it goes to save the policy. Notice this error saying failed to create policy. That's because I have not given Bob permissions to create this policy in OpenShift. And what as an administrator you'll notice in the audit log is there's a detailed audit logging enabled through OpenShift that says Bob tried to create a policy at this time with this metadata, and that was denied. So let me log out as Bob and come back and log in as a different user into OpenShift. So let me log in as user Sally, who happens to be in, say, a business unit A. And when I log in as Sally, now you'll notice that in addition to that default tier, I now have a business unit tier, which I've given Sally permissions to view. And Sally can go ahead and add permissions in that business unit. Assuming I haven't made a mistake there, but either way, Sally can create permissions, and I'm not going to do that because I'm going to come back in and do another login as a different user. Now, let me log in as an admin user, in this case as an InfoSec admin. Now, in addition to just the default tier and the business unit tier, now you notice that this admin, InfoSec admin, has views on not just these tiers, but also the additional tiers, an InfoSec tier as well as a security operations tier. Now, what that means is that these permissions are all being exposed to these users or being granted to these users based on OpenShift RBAC permissions. To show you what they look like, where did I put that? So there's the permissions I've created for Bob that says that Bob is allowed to work on these artifacts by just watch and list, and specifically the tiers that he is given access to is the default tier, and all he can do is get the policies from the default tier, right? And this is something that's being associated with user Bob. It can also be associated with other users in OpenShift. And these RBAC controls are standard Kubernetes and OpenShift RBAC controls that we enforce with policies, right? So when we have that cluster running, now we've logged in as a security user, right? And so now I'm going to get to that second example of now that we've got users defined and we've given users permissions to add and create policies in specific tiers based on their role. Now I'm going to get to the next sort of section of the demo, which is how do I enforce a PCI compliance policy? So coming back to this application, what we're going to do is we're going to create a policy at a higher level InfoSec tier that says that only PCI compliant pods can talk to other PCI compliant pods. At which point, what will happen is C can talk to AP, AP can talk to BP, and BP can talk to DP. But this other pod B, which is running without this label compliance equals PCI, will no longer be able to talk to the other pods because it is missing this PCI compliance label. And so what I can do is if I now apply this policy, so if I do that, the policy I'm going to apply will show up in this InfoSec tier, right? So right now I have a couple of things to allow the UI application to work correctly and just a default implicit pass for things to pass to the next tier. So now if I do a OC apply, I can do an OC create, doesn't really matter. InfoSec tier PCI. I'm creating these new policies here, and if you go to the UI, you'll notice that these policies have been created. I could have just as easily created the policy via the UI. So for example, I could create a test policy. I could have done this globally, and I could have done this globally, for example. I could have added a rule that said, allow any protocol if compliance equals PCI. Save that, and apply that in all pods which are tagged compliance equals PCI. Now, had I saved this, which is essentially what I did by applying that OC command, I could have done the same workflow via the UI and save that as a YAML. So in effect, what you can do is rather than editing YAML by hand, the intent is that we give you a nice UI where folks can edit the policy, save it as YAML, run it through their CD system. So really move towards managing policy as code rather than the earlier methodologies that people have used, which is very error-prone ways of editing YAML by hand and leaving it up to the developer. Any case, now that I'd applied that policy via OC apply, notice that these policies exist, and this is all being applied at the InfoSec tier. In other words, these policies are being evaluated before the security operations tier, before the business unit 1 tier, before the default Kubernetes tier. And so what that means is these policies that we just applied take precedence based on the fact that InfoSec takes precedence over the developer, right, within the organization. And for example, if you look at what this policy says, it says it's going to pass traffic for pods labeled compliance equals PCI for any traffic that is destined to a compliant PCI compliant pod, right? Now, if I come back and look at this application, if I do a reload here, notice that this pod B, which is missing the PCI compliant pod, is no longer able to talk to the other pods because I've now created this policy at the InfoSec tier, which overrides what the developer might have said. I can now enforce things like PCI compliance rules dynamically and in a declarative fashion, independent of what the developer has said. And so the sort of function that we are enabling in this model is that if you go back and look at how security organizations used to create policy in the past, every time a developer needed to roll out a new application, in the real world, that developer needs to submit a workflow request to an InfoSec team, and then the InfoSec team typically has someone go back and review that rule, review the application, add a firewall rule in a centralized firewall. And usually that process takes anywhere from a few weeks to a few months, like in the case of the customer we were talking about. It used to take them 3 to 4 months for that policy rule. And so the other factor that you notice is that today, much of those rules are static, tied to things like IP addresses. And so once a rule is added, no one goes back in and cleans up that rule. So that rule remains as a craft in your infrastructure, which never gets deleted. In this case, what we have is a dynamic set of rules which are applied in lockstep with the application, but tied to organizational hierarchy. So we are allowing InfoSec teams to codify the policy rules and enforce that at all times for all given applications, so that individual application rollouts don't need to go back and have this 2 to 4 month wait period while the InfoSec team reviews, hey, is this request valid or not, and is this application violating our policy? So that's the second sort of workflow I wanted to demonstrate. And third one was some of the operations workflows. And in the CNX Manager UI, you can get lots of individual views, both current and historical, showing what was the policies, what was the data flow, how many applied and denied packets, and the sort of drill downs into going back and looking at the total policies in effect, the number of unused policies, for example, although it's showing that these policies are currently unused. It can show the number of endpoints, so you can actually go back and drill down in endpoints, look at the labels, be able to edit all of these, look at nodes, what's running in an individual node. But even beyond that, we also integrated to other environments that customers tend to use. So for example, if you want to have this viewed via, say, a Prometheus or a Grafana dashboard, we can give you sort of views into that. So for example, if what I'm showing you here is a Grafana dashboard, where you get these detailed historical logs of traffic denied by policy. So you can drill down into specific inbound and outbound packets. You can define thresholds as to what you want to happen when a certain threshold is exceeded. For example, do you want to start logging traffic? And as I'll come back and show you that log action in a second. But one of the things you'll notice is I've been sending traffic to this infrastructure while we've been speaking. And you might have seen my Slack alerts been popping up in the back. So as an example, one of the alerts that I've configured in my CNX demonstration is the ability to send alerts, in my case, to Slack. You can obviously pick your favorite alerting system with platforms like Prometheus and Grafana. But I've been sending alerts to Slack, and you can actually drill down as to what threshold you want alerts to send. For example, if I've set the threshold to, if I see 50 packets a second, 100 connections per second, where someone's trying to violate policy, I want to get an alert sent to Slack. So along with that Slack alert, one of the workflows that we automate with CNX, but I'll show you here in a manual way how you can do this as well, is if you go to the CNX Manager dashboard and I go to the specific policy. Actually, before I do that, let me just start a log capture. Okay, right now I'm not logging any packets. All right, so I've turned on just system logging. I can obviously redirect that to Fluentd and get a nice graphical view as well in Fluentd and display it by Kibana. but for now I'm just going to show it by syslog. And now if I actually go to my, let me clear my filters here, and go to the specific policy, PCI policy, and I'm going to edit it. And this can all be done in a declarative fashion with automated rules. But let's say I'm going to duplicate this rule, this deny rule. And in addition to denying it, I'm also going to log it. So now I'm going to say log this protocol and save that rule and save that policy. Now, if I go back to my logging here, you notice that I'm actually getting packet logs, like the 12 tuple headers of the different source and destination IPs, including other metadata that we can optionally log as well, that says these packets are being received from these sources on this particular interface. This is something that can be used by audit teams within a typical enterprise to go back and say things like, at 7 p.m. last night, here was the state of policies in the infrastructure. Here were the attempts that were made to violate policy. Here are the detailed packet captures that tell me what was the actual traffic flow, where was it coming from, potentially correlated with both labels and policy. But all of these are designed to be to work as an automated workflow where we are helping move what used to be a number of manual workflows where you have security teams, where you have network operations teams, you have other teams that need to respond with manual intervention, to now a completely and highly automated infrastructure, not just within OpenShift, but across the entire infrastructure with bare metal hosts as well as virtual machines, as well as in the public cloud, where we've become the platform of choice in a number of the major public cloud environments as they come to dynamic policy-based microsegmentation in lockstep with orchestrated environments like OpenShift and Kubernetes. And so what we really help transition this environment to with customers like the global automaker that Amit referred to is moving them away from this 3 to 4 month period where they need to enable manual controls or different application rollouts to now a completely automated infrastructure with all of the workflows, including the automation for that around auditing and logging and so on, as a completely automated workflow. So I see I've been getting some chats and comments in Blue Jeans. Let me just wrap up here and let's get to the comments if we can. So where do we go from here? So what I've given you a preview for is just 2 of literally dozens of interesting workflows that we've enabled for a number of our customers around how they can speed up and automate the application workflows in lockstep with OpenShift, not just within the OpenShift platform, but also across the infrastructure beyond OpenShift. But at the same time, not compromising on security and the fact that now they can get these in-depth audit logs, in-depth history of policy, and in-depth instrumentation and metadata, but in a truly dynamic manner. And so join us at this link should give you more detail on the collaboration that we have with Red Hat and how we're making this an integrated turnkey experience with OpenShift. We also have a community Slack channel where with projects like Project Calico and SPO, we collaborate very closely with the communities that are enabling these capabilities. And so come join us, come talk to us. We will continue to highlight some of the more advanced workflows as we have more meetups and events in the future. And that said, I will now transition to any sort of questions and discussion.
So thank you very much, Karthik and Amit. We do have one question, and Peter's going to have to jump off it in a little bit, but he wanted to know a little bit more about the types of policies that can be created. Can package scans and contents be part of a policy? Is the session aware and able to validate based on an established session, known session, etc.? And then sort of the types of validation he's interested in. There's valid HTTP traffic, valid DNS traffic. It's a long question. Valid traffic that the protocol, all of that sort of stuff. So can you take a minute and try and address that?
Absolutely. Thanks for the question, Peter. And Peter, it's been a while. We should catch up at some point. But yeah, there is a number of sort of advanced capabilities we have with CNX, which enable a number of sort of scenarios. So for example, you asked the question about things like following traffic profiles. There is a number of features we built in terms of things that we've linked to capabilities that exist in Linux and RHEL already, such as plugging into leveraging contract in the Linux kernel, for example. Again, CNX is purely is something that leverages the standard Linux data paths. In other words, we just create routes in the Linux kernel and IPsec rules in standard RHEL or other distributions of Linux. But for example, here you'll see there's some additional features we have. For example, one feature we have is 3D-net, where you can apply this on forward. There's a number of sort of capabilities here around enabling a few advanced scenarios in addition to the actual policy editor, where we have some specific rules and you can log, pass, deny, and perform a number of sort of additional actions, not just on endpoint selectors. You can do this obviously on namespace selectors as well in OpenShift, or you can do this on CIDR matches. We have additional features around network sets. But all of this is tied to standard capabilities that are enforced by the Linux kernel. Again, this is the standard RHEL kernel that's shipping today. We don't insert any kernel modules. We're not in the actual data path, but essentially we create the rules in Linux to enforce that policy. Another example is the do not track option here is you can actually turn off do not track for applications like memcached, which is another example of an interesting application you encounter in the real world, where you might have a large number of short-lived connections and you may not want to turn on contract. So there are a number of sort of scenarios there. I think the cases that you are calling out, we've actually encountered a number of scenarios like that as we've talked to customers over the last year and a half. And those are all things that we do have enabled in the product. Awesome. In terms of valid HTTP traffic, valid DNS traffic, and so on, one thing I did not demonstrate in this demo, but is something that we have in tech preview right now, is Calico's application policy. And specifically there, you have the ability to specify things like, I want to allow HTTP gets but not puts. So I want to allow maybe this particular application transaction to occur but not. And that's a pretty innovative and advanced functionality that we announced at the last KubeCon. We have it working in tech preview now, and something that we have seen a lot of excitement. So at some point, maybe Diane, if we can get an invite back, we'd love to come back and demonstrate the application policy integration that we have with Istio and CNX.
That would be great. We'll see you all at Red Hat Summit, I'm sure, and we can schedule another briefing there. And I'll be in Community Central in a big booth that they've given me for OpenShift Commons, so please do come and find me there. And we can schedule a briefing, or if you have another topic that you're passionate about and you want to schedule one or hear about it, let me know there too as well. We're at the end of our hour, so I want to be respectful of everybody's time. And thank you very much for this session. And I will get it processed and hopefully up by the end of today on blog.openshift.com and up on our YouTube. Thanks again, guys. And Karthik, it's wonderful to get to do this again with you.
Thank you, Darren, for hosting as well. I appreciate the time and the planning that's gone into this.
Thanks, Dan.
Take care.